Welcome everybody to the December edition of the Mugs to Donuts newsletter. Here we're interviewing Maria Gillespie. Can you tell us a bit about yourself?
Well, I'm a professor at Colorado State University, a math professor. I study combinatorics, and I coach the Putnam team here at CSU. I took the Putnam all 4 years that I was an undergraduate at MIT, where Carl is. And that's, I do mathematics. I run. I have a family. I have twin, almost 3-year-old girls, and that's about the summary of me.
All right, so you mentioned that your area of research is combinatorics. How would you describe combinatorics to, say, someone who isn't really familiar with math beyond calculus or what you would learn in high school?
Yeah, great question. So combinatorics is the study of finite sets of objects and combinations of them. So combinatorics to me comes from the word combinations. And so an example is, say you want to know how many different ways can you get dressed in the morning if you have 10 shirts and 5 pairs of pants. You would multiply 10 by 5 and say there's 50 possible outfits because you pick 1 shirt and 1 pair of pants and you multiply those combinations. Now that's an easy combination to count, but still we've saved a lot of work by multiplying 10 by 5 rather than like listing all the possible shirts and all the possible pairs of pants and sort of, drawing all the possible combinations. And so combinatorics is the study of interesting, mathematical objects that involve some structure that maybe we could get a handle on using algebra or other methods. And we're usually interested in counting those. Enumeration questions are central to combinatorics. So that's what I would say combinatorics is.
How did you choose combinatorics for your area of research?
Yeah, so I thought about this question. Thanks for giving me a tip on some of the questions that were going to come up. And I think that just like in Harry Potter, where they say the wand chooses the wizard, Harry, I think combinatorics chose me. So I feel like I was just drawn into it. It was, it sort of called me, over the years. But there was a bunch of moments that I could sort of point out. When I was an undergraduate, I thought I wanted to study, when I first went to MIT, I thought I wanted to study astrophysics. I knew I loved math, but I, wanted to do something applied or something with the mathematics. And then I took a bunch of math classes, and the math parts of the physics classes always were the ones that drew me in, and the math classes I found more interesting than my physics classes. And so it kind of went like that. And in particular, in the second semester of my freshman year, I took a algebraic combinatorics class with Richard Stanley. And he's, one of the leading experts in combinatorics. And it was just such an inspiring class. I loved every minute of it. And I also got a B+ in that class, which for me was just unacceptable, right? For me to get a B+ in a math class. And I think that actually sort of inspired me to study combinatorics, because it was sort of this thing that I had to prove that I could do it, And so I ended up taking more combinatorics classes, but I also just found, I just really loved it. Every time I tried to study a different area of math at an RU or something like that, I would always end up focusing on the combinatorics aspects, and it just sort of chose me. So that's how I got into it.
All right, so you talked sort of about your undergraduate experience. Moving to graduate school, I believe you attended UC Berkeley, is that correct?
Yep.
How did you choose that?
Yeah, UC Berkeley was a great place. How did I choose UC Berkeley? I applied to a bunch of different places, got in a couple places, and UC Berkeley and Michigan at the time they both had really strong combinatorics groups. They still have strong combinatorics groups, but at the time, those were the ones that interested me. I wanted to go somewhere different from my undergraduate institution. They usually recommend that to just branch out, And so, I was deciding between the two, and Bernd Sturmfels, who was at Berkeley at the time, he does sort of computational and combinatorial algebraic geometry. He convinced me to go to Berkeley over Michigan because the advantage of somewhere like Berkeley is it's right next to MSRI, which is the Math Sciences Research Institute. So they constantly have mathematicians flying in for programs and, people interacting with new ideas like that. So it just had a lot of opportunities there. Not that anything like Michigan is a bad place by any means, right? So it was a hard decision, but I did choose UC Berkeley. And ironically, even though Bernd Sturmfeld sort of recruited me, I didn't end up working with him. That didn't work out. But I found the perfect advisor, Mark Heyman. He was, and actually ended up, he's an academic sibling of Richard Stanley. So it's that sort of, the same thing that got me interested in undergraduate. I ended up working with sort of the same kind of field. So I worked with Mark Heyman at UC Berkeley. It was a really good experience.
Did you have a thesis problem in mind yourself, or did you get one from your advisor?
Yeah, sort of both. I mean, I would say my thesis area, like my area of research, definitely came from what my advisor taught me and, the things he told me to read. But then as I read things, I sort of asked him at one point, like, can I work on this problem? And that was my sort of choice. And he said, yeah, that sounds like a great thesis problem. And that's kind of how it worked. So it was a combination of both.
So I guess you've talked about some courses and people who've been influences. Is there like one book or person or course or some other academic entity that has had a major influence on you?
Yeah, I mean, there's so many entities that have had an influence on me. I mean, I guess starting from when I was a kid, I mean, my dad was a mathematician and he certainly had an influence on me growing up. I mean, he taught me a lot of mathematics in high school, especially. But as far as a book, one that comes to mind is Bill Fulton's book on young tableau, which I read cover to cover my first year of grad school at UC Berkeley. And it's just this beautiful book. I mean, young tableau are very sort of, I wouldn't say niche, but it's a very specific mathematical object, but they connect to so many different areas. I mean, they're combinatorial. A young tableau is basically a way of filling boxes in a grid with numbers. And there's with certain conditions on them, like they have to be increasing in certain ways. And there's different types of young tableau you can study. And they connect to symmetric function theory and representation theory and geometry and all these different areas just by doing this basic combinatorics. And that really drew me in. So when I read that cover to cover, I mean, now almost all of my papers involve something related to young tableau. I think once I discovered them, it was like, my thing. But as far as other, influences, I mean, so many mentors, I can't even, name them all. I mean, Joe Gallion, right? So I went to the Duluth REU and he was, of course he runs the REU. So people like that, have been inspirations to me. And I honestly, there's probably like very important people that I'm not naming. I mean, I can't possibly name all the people. But as far as books, that one, Enumerative Combinatorics by Richard Stanley, all these classic books, there's so many. So.
Tell us about a problem you particularly like. It could be a contest problem or a research problem or a Putnam problem. Yeah,
that was also a hard one to think about. But the one that I settled on when I was thinking about this is, I think for me, the most exciting thing is when I find a combinatorial proof of something that that usually has, its standard proof is algebraic or geometric or something like that. And at the one point, I just started randomly thinking about, is there a combinatorial proof of Benet's formula for the Fibonacci numbers? And so this didn't particularly come from a contest or anything. It was just something I was thinking about at one point. So Benet's formula says that the nth Fibonacci number is, given by this crazy formula involving the square root of 5. You have like 1 over square root of 5 times the sum of, and the difference of two nth powers of 1 plus square root of 5 over 2 and 1 minus square root of 5 over 2. And the fact that that's the formula for the nth Fibonacci number, where the Fibonacci numbers are this sequence 1, 1, 2, 3, 5, each number is just the sum of the previous two numbers. That's a sequence of integers, and yet its explicit formulas in terms of square root of 5s. And, all the proofs that you see of this are always induction or generating functions or some other algebraic method, things that involve just manipulating algebraic symbols. And I really wanted sort of to find the meaning in these square root of 5s and what this formula meant. And so the question is there a combinatorial proof of the form, take some combinatorial object that the Fibonacci numbers count, like the number of binary sequences of length n in which no two ones are consecutive. That's one of the classic combinatorial interpretations of the Fibonacci numbers. Can you understand why Benet's formula also counts that by a counting in two ways kind of proof? And usually you would say, well, no, there's square root of 5s. But if you just do a tiny bit of algebra to get rid of the square root of 5s by expanding both of the nth powers using the binomial theorem, canceling the square root of 5s that appear, and then now you have a summation and a sum in different, well, there's some negative numbers, but it's a summation of integers at least. And then you can do an inclusion-exclusion type of argument to actually argue that it is the number of binary sequences with no 2 1s next to each other. So I worked this out. I spent a day or two doing this and put a solution on my blog, which is mathematicalgemstones.com. You can look it up. So I just did it for fun, but I would love to hear any other combinatorial proofs of this. There's never just one combinatorial proof of a fact. So like this kind of thing. So for people out there watching it, if you can find a combinatorial proof of Benet's formula, I would love to hear it.
Talking about research recently, most of the papers you've written recently have been joint papers, so collaborations with other researchers. How do most of these partnerships come about? How does that work?
Yeah, I think it's honestly different for every partnership, and I think some of them just come together like by magic. Like it's another one of these things that feels like it's out of my control, like how did I choose combinatorics? I think it chose me. For these partnerships, some of them, the most sort of common one is you just sort of meet somebody at a conference or at a seminar or even on Zoom these days, right? And you both have an idea about something. You just get talking about math and you have an idea on some problem and you say, hey, we should work on this. And you set up weekly Zoom meetings, and that's now, right? In the past, it would be emails and, let's meet at this next conference to work on it together. That used to be how it worked, right? And I'm actually glad for the Zoom meeting thing, less flying. And then you just sort of work on things until it comes together. There's, specific partnerships that I think are really valuable. I think the advantage of working together with people is that, they might have a slightly different outlook on things or slightly different skills, and you can put them together with what So I think it's, a lot of the best papers I've read recently are, 2 or 3 authors, I think is the sweet spot. I don't know, at least in my field. I think when I work alone, I used to work more solo, I guess, when I did like RUs as an undergrad, at the Duluth RU and things like that. And I enjoyed that too, but I think there's just, more you can do when you have a bigger team. So I prefer that. And even the last 2 solo ideas I had, I collaborated with graduate students here at CSU because this way it would also double as like a mentorship kind of thing for them. We could see if we're a good advisor-student match, So I think there's advantages of working with other people. And as far as my specific collaborations, the one that I've collaborated with the most, Jake Levinson, appears all over my CV, right? So he, I met him midway through grad school. He was another grad student at Michigan, actually, which was the other school I was thinking of going to. When we met and we first talked math, it was just like this crazy, idea generating factory between the 2 of us. So when we talk math, the ideas just sort of flow, and it's really a special thing, So sometimes it's just you find the right person and you collaborate really, really well with them and you write lots of papers with them. So I think, I'm grateful whenever I find something like that, it's very special. So there's been lots of good collaborations I've had lately. I feel lucky to have all these great collaborators to work with. So that's my answer.
What about your joint papers with family members? That's kind of interesting.
Yeah, that too. Yeah. So that was really fun. One of them was just like, we have so many math people in our family. We're like, we should write a paper together. And we just did it, over a summer. And then the other paper I wrote with them was sort of more organic. Like we all just ended up proving something. And so we wrote it up, So there's, it's very fun to work with them.
So outside of math, what are your biggest interests?
Yeah, well, I've mentioned in my introduction, when I tell me about myself or whatever, that I have almost 3-year-old twins. They're going to turn 3 next week, twin girls. And so I I mean, they're obviously a big part of my life, right now. And my husband, our family is essential focus. And then I love running. I'm a distance runner. I still run. So those things, yeah, outside of math, I mean, I don't have a lot of time for anything else right now. So with 3-year-old twins, you just don't have a lot of time to do other things. So I run, I take care of my twins, and I do math. That's what I do.
Do you enter anything like 5Ks or half marathons or marathons?
Yeah, I've been doing trail runs, so like trail marathons and things like that. I've even done like ultra running, so like trail 50-milers just through the mountains. That's kind of what I'm into right now. I've done road marathons and stuff like that in the past. I started out as a cross-country runner in college and high school. Well, actually in high school, right? And then in college, I ran collegiate cross-country. So that was, when I was younger, I did all the shorter, faster stuff, and now I'm doing the longer, slower stuff. But it's a hobby that kind of keeps me grounded.
Do you sometimes come up with math ideas while you're running?
Yes, I do. In fact, I can even picture and name the specific places on the mountains that I was when I had the idea. And yeah, I think it's also just where do you come up with math ideas? I mean, you come up with them wherever you are, right? And I run a lot, so the probability that I'll have an idea on a long run, right, is pretty high, right? But most of my long runs, I don't randomly prove a theorem, It's just a probability. Sometimes I'm in the shower and I have the idea. Sometimes I'm on my run and I have the idea. Sometimes I'm walking to the bus station and I have the idea. That's, so.
So since it sounds like running is a big part of your life, how have you, throughout your mathematical career, balanced that with academics, specifically in college?
In college, running varsity cross country was a big time sink. And one of the things I did to balance it was not do track, so track is in the spring, cross country is in the fall. Most people do both when they're collegiate runners. I didn't have the time to do both. So I focused on cross country, much to the dismay of my coaches at MIT, but their dismay was, I didn't want to cause them any suffering, but I also wanted to focus on my academics. And so that's how I balanced it, in college. As for balancing it now, I use running as my one hobby escape kind of thing. It's the one thing I do for myself. So I think it's just sort of an important part of my whole life balance,
With your family, you run Pruvit Math Academy, a summer program for high school students looking to bridge the gap between calculations and mathematical proofs. How did that get started?
Yeah, so we were just thinking about things that we could do together as a family because we all had these, skills in math and math education. And so we put that together and we ran a summer program a number of years. We actually ran it at CSU a lot because my brother went here I'm at CSU, Colorado State University. My brother went here as a grad student for math and stayed in the area. So we have connections to here. So we ran it here a bunch of times. And then, I ended up applying here for jobs because I liked the area. So as for, why we did Pruvit, it's, bridge the gap between problem solving and proofs, because I think there's a big there is a gap there. There's some programs that focus more on contest-based, fast mathematical calculation. And then you move up to the sort of research programs, MIT primes, RUs, things like that. And they assume you know proofs already, even if maybe all you did was computation, right? And so there's room for connecting that and just really focusing on what is a proof and what does it mean to be rigorous. And this is something that I think we see at the college level too, which I'm very glad some universities are, making courses now that are called Introduction to Proof. And that does bridge that gap in the sort of curriculum where I saw, at least when I was an undergraduate at MIT, I saw some students, go through, they would do really well in the calculus courses, and then they would try real analysis or they would try algebra, and all of a sudden they have to do proofs and they've never seen what a proof is in their life before. And so I think it's, that's the gap that we were trying to bridge with that program, but at the high school level.
So how has how has the focus and kind of the implementation of the program changed, of course, as everything had gone virtual?
Yeah, so in 2020, we ran an online summer program. We were intending to do it in person, and of course, we switched it to online. And that went really well, actually. So there was some advantages to the online program. I mean, it just sort of forced us to rethink it a little bit. We had a fewer number of students. Certainly the cost was lower. I mean, nobody had tuition. We didn't have to reserve dorms and food and all that stuff. And we actually split up the students into groups and ended up doing like mini mock research problems with them as we were teaching them what proofs were. So it was really, really a fun program. And actually 2 of those groups ended up publishing, in student journals and things like that. So it really turned out well. But yeah, and as for how things are still changing in the pandemic, I mean, I unfortunately had to take a step back from Pruvit Math Academy. I've left the organization, which was hard because it's my family, so I fully support, of course, Pruvit Math Academy, but my dad and my brother and my mom are sort of bringing it in a new direction now. And I'm excited to see where it goes. I don't know exactly what they're doing with it, but I think they're working on putting the materials online and making them more online accessible. So the pandemic really did inspire us to change things in that way. And I just had to step back just because of my, role as a mother and, life changes, so it's just a matter of time commitments and things like that. So.
What advice would you give to mathematically oriented college students who are beginning to figure out their interests and career possibilities?
Yeah, so I think when you're in college and you're just starting to figure things out, just explore. I mean, take a bunch of classes, do a bunch of activities, do summer internships, do summer research projects, try things. And, hopefully if you try things enough and follow your heart, when you have an interest, pursue it, and see where it takes you. And by the time you're a senior, hopefully you have some idea of what you want to do. You could apply for grad schools or jobs or whatever. And it is a exciting and scary process, but you'll figure it out. It's also not, nothing is binding. You can easily make a career change. That's okay, right? Lots of successful people do that. So just explore, have fun. And remember that grad school is free, which they pay you rather to go to grad school. It's not like you'll get further into debt, which a lot of college students don't know. So you don't necessarily have to, to do like a PhD in math, for instance. You won't go further into college debt by doing that. They give you a stipend. So that's my advice.
Great. So a little bit earlier, we talked about how things have shifted during the pandemic. So it seems like you've sort of been at the forefront of some of this virtualization and teaching courses online, giving talks online, helping to make that transition easier for people. Can you tell us a little bit about what you've been doing on that?
Yeah, I don't know if I was at the forefront. I mean, that's with how much awesome technological tools and advances everybody has discovered. I think there's been a big movement of that form, in the pandemic. But I did take an interest in it for sure. I mean, when the pandemic hit, honestly, I think it was like sort of a pandemic coping mechanism for me. It was like I had to see the silver lining with so much, so much isolation and distancing and, people dying and illness and, all the horrible things that were going on. At least, there was this big opportunity to discover what we could do with virtual learning, what we could do with virtual talks, whether we could move academia away from the big carbon footprint we have from flying to conferences all the time, right? And so I was like, oh my God, I have to use this opportunity to do something good, So yeah, I dived into it. I mean, the first thing I did was all the conferences that I was going to go to and give a talk in and hear other people's talks, they were all canceled. So I sort of put out some feelers and got together a group of 4 organizers in my research area to run an online conference called AlCoVE. That was Algebraic Combinatorics Virtual Expedition. And so we put together AlCoVE, and it was basically just so that all the people in my field, algebraic combinatorics, could come together on Zoom and give talks and listen to talks. And we really pushed the boundaries. Even at that time, it was in like June 2020 when we ran it. At that time, Zoom didn't have all the features it has now. We didn't know about these things like gather.town and all these other tools that people use now. And we just, pushed the breakout rooms to the limit. We were doing like, moving people between breakout rooms. We had a poster session. It was, we did everything we possibly could because we were just like, okay, what can we do virtually, And it was a really great learning experience. We had so much fun with it. It was a good first, conference in our virtual conference in our field. And I think, now we're running that again. I mean, now we did AlCoVE again in 2021. This time we had an NSF grant, so we had better technological tools. We're doing that more in the future. And I think it's just such an opportunity to create things like that, So I'm excited to see where AlCoVE is going to go. As for teaching, I also made an open educational resources materials with my colleague who also was teaching the other section of undergraduate combinatorics in the fall of 2020. Rachel Priest and I taught that and worked with Henry Adams here, who is another instructor who does combinatorics sometimes here, and some grad students here. And we wrote this book called Counting Rocks. It's available online for free. It's a free open educational resources textbook. And we also made videos for it. Which I set up a whole green screen in my house, and I had like math floating behind me that I would like point to like a weatherman. I really kind of went all out on it, and I have instructions of like how I did this with my green screen and what software I used for that and for my research talks. I have it on my blog. I have a bunch of blog posts on this at mathematicalgemstones.com. If anybody wants to check it out and emulate that, I posted about what I figured out.
Sounds to me like you're in the forefront.
I just don't think of myself as on the forefront, but I don't know. I'm sure there are other people out. The thing is, I'm sure there are other people out there who know more than me on this. And I was inspired by many other people who, did things like this. So.
Do you think these meetings like the joint math meetings is going to survive in their, not in their current?
You mean in their in-person format?
Yeah. 4 days.
I don't know. I mean, I guess my philosophy is that, there are definite advantages to in-person things. I mean, in-person teaching for sure. I don't think classes like at the college level or definitely not the high school or lower level should be online. I mean, if you can get together with people locally and sit in a classroom and do math, I mean, there's just something, intangible about that you just can't replace virtually, no matter how good virtual technology gets. It's much less distracting. Everybody's there and present, and for conferences, I think there's an aspect to that too. I mean, networking and, meeting people, it just happens much more easily and organically at in-person conferences. So I think there is a place for those in-person conferences where everybody gets together. But on the other hand, I really worry about the climate impact of everybody flying everywhere. And I wonder if we could strive as an academic community to limit the number of conferences we all go to. So maybe we do have the JMM because that's like the one time everybody gets together, right? But then on the other hand, all these flying to seminars just to give one talk in a local thing, you could just be projected on a screen. It's easier, right? And you could even it's even more accessible for people who might not be able to travel or people who are in other countries. And so I think there's a huge advantage to switching to sort of moving in that direction. And I have been sort of pushing to make sure that at least hybrid options are available in things like this. And, I hope that we could drastically reduce the carbon footprint of mathematics. I think that's a good thing,
I hope RAU programs never go virtual. I mean,
no, that's the kind of thing, right? I mean, there's certain things that have to be in person, but we can ask which things don't, and that's, I think, the silver lining. So I don't know. That's my thoughts anyway.
Well, I think that's all we had to ask. Thank you very much.
Well, thanks so much for interviewing me. This was really fun. And I love the questions that you put together. I think it was really creative in how you're trying to tell a story or whatever. I'm excited to see these newsletters. I'm glad you guys are doing this.